Alright, at the bottom of the energy notes there were some problems that we worked through in class, and I'm going to go through those for you now. Hopefully you can see these well enough. So we got a car, 875 kilogram car, speeds up from 22 to 44 meters per second while passing another car. This is our mass, 875 kilograms. Make sure this is low enough for you to see here. Two questions. What was the initial kinetic energy of the car, and what was the final kinetic energy of the car? Right, so to calculate kinetic energy, remember kinetic energy, our formula was 1/2 mv squared. 1/2 mv squared. So we simply plug in the numbers that we have. We're given the mass is 875 kilograms, so we'll plug in 1/2 times the mass of 875 kilograms times the velocity. Now this velocity here, we want initial kinetic energy, so we want the initial velocity of the car, the initial speed, and it goes from 22 to 44, so the 22 will be the initial speed. So we'll plug 22 in here, make sure that that gets squared, and all you have to do is simply calculate that out. 875 times 22 squared divided by 2, and if you do all that, you should get a kinetic energy of 211,750 joules. Now that's a really big number, and if you're like me, you don't like big numbers. So we can actually change this to kilojoules. Sorry about that, E sub k. To change joules to kilojoules, all you have to do is move the decimal place 3 to the right, or to the left rather, sorry, 3 to the left. So this would also be 211.75 kilojoules. Either one of those would work as the answer. We have another problem here on the back. Let's calculate kinetic energy again. We have a rifle. It can shoot a bullet with this mass, 4.2 times 10 to the negative third kilograms, at a speed of 965 meters per second. So we'll calculate kinetic energy again. E sub k equals 1/2 mv squared. And we simply plug in our numbers. Our mass is 4.2 times 10 to the negative third kilograms, and kilograms is correct. Remember that kilograms is the unit we have to have mass in. So 4.2 times 10 to the negative third. This is our notation for scientific notation that we use, since that's the way we enter it in our calculator. And the speed is 965 meters per second. Again, make sure that gets squared. By the way, this 965 is pretty outrageous, outlandish for the speed of a bullet. So 965 squared times 4.2 times 10 to the negative third divided by 2. And if you work all that out, you should get a kinetic energy of 1,956 joules. And we can change that to kilojoules again by moving 3 decimal places to the left, and you would get about 1.96 kilojoules. Alright, and then the next one, we're going to move down to the bottom of the page, and we're going to look at this problem. We have a 50 kilogram shell. It's shot from a cannon to a height of 425 meters. Kind of sounds like the old projectile motion problems that we used to have. Alright, the first question is, what's the gravitational potential energy of the shell at this height? In other words, this 425 meters here. Gravitational potential energy is U sub G, and the formula is mgh, mass times gravity times the height. And that's going to be, the mass is 50, and it is in kilograms, so that's the correct units. G is the acceleration due to gravity, and that's 9.8. And remember, we always enter positive in here for energy. Energy is always going to be positive. And the height at this point is 425 meters. Pretty simple. 50 times 9.8 times 425, and you should come out with 208,250 joules, which is also equal to 208.25 kilojoules Both of those are correct. Once again, decimal places here, 1, 2, 3 to the left to go to kilojoules. And for the last question in class, I changed it just a bit. I marked out change in. I'm not going to mess with change in potential energy right now. I just want to give you practice calculating potential energies. What's the potential energy when the shell falls to a height of 225 meters? So once again, potential energy equals mgh. Mass does not change. Gravity does not change. So mg, here's the mass, here's the gravity. Those don't change, but what did change is the height is now 225 meters, mgh. 50 times 9.8 times 225, you come out with a potential energy of 110,250 joules, which is also 110.25 kilojoules. So there's your video on how to calculate potential and kinetic energy.